The pros and cons of nuclear energy include that it has less of an immediate environmental impact. So again, it's going to put out less greenhouse gases than fossil fuels will. So there'll be no carbon dioxide produced, very little other than water vapor is released from a properly functioning nuclear power plant. And eventually, this might be able to generate hydrogen fuel either as a byproduct or it may advance hydrogen fuel technology. Um, the the negatives are that it generates radioactive waste, and it generates radioactive waste both as the byproducts with the spent fuel rods and also radioactive mining waste. Many steps require fossil fuels like the transport and the mining of uranium. And don't forget that any negative effect of mining can be associated with nuclear energy as well. It's very expensive, and nuclear energy is not renewable. So uranium is a non-renewable source. But if you look here at the amount of land, it uses less land, less fuel a day. We have about 100 years worth of nuclear power. Air pollution is low. Climate change risk is really, really small, but lots of radioactive emissions. And water pollution has potential to be very severe at disposal sites. And while fossil fuels have a short-term risk from a catastrophic accident, the long-term risk from a catastrophic accident with nuclear energy is high. You also have to have additional security because of the potential to take it for to rob it for nuclear weapons. The annual occupational death is usually less than one, and we aren't always certain about the risks because when the risks happen, they're terrible, like mind-blowingly terrible. So 20% of our energy is from nuclear energy. And what keeps it affordable is that we have government subsidies for it. The nuclear power plants are very expensive to build, and it takes a long time to recover those costs when producing electricity. Also, keeping the power plants up to date, so fixing the technical and safety issues in the plants are expensive. A meltdown is when, at high temperatures, the metal casing that contains the uranium fuel can melt, and that releases radiation. The probability of a meltdown is low. You have to have several things go wrong before that can happen. But the public perception of nuclear meltdowns is that they happen frequently. And we have some sites of major accidents. So 3 Mile Island was a nuclear power plant in the United States in the Northeast. And while we did have technically a meltdown, all the safety measures in place worked. And so radiation did not escape from the power plant at 3 Mile Island. At Chernobyl, we had a full meltdown. And the Ukraine, had a full meltdown in 1986. And the safety measures didn't really work. Like everything that could go wrong kind of did. So the tower blew up where they had it. Radiation escaped. Radioactive clouds were spread essentially all over Europe. So again, in 1979, 3 Mile Island, we had a 50% meltdown, but our containment building worked and kept radiation from escaping. There was no human casualties, no substantial environmental damage, but it did lead to the cancelization of new power plants in the United States, and it kind of brought an elevated public appreciation of nuclear energy. 1986, Chernobyl was the worst accident in history, and that's when we had a couple of explosions here that blew up essentially the control tower, which means that all the radiation that should have been contained in this containment tower spread out throughout the atmosphere throughout Europe. The death toll was anywhere from 10,000 to 100,000. Ukraine was part of the Soviet Union at the time, and the death toll was most likely underreported. Additionally, we had people dying of thyroid cancer in the area for years. Things like mushrooms you were not able to eat them for a long time, particularly in these higher radioactive areas, parts of Europe. Today, about 31 countries use nuclear energy to create electricity. But that means that these countries have access to the spent nuclear fuel, and you can use that to make nuclear weapons. So the safe storage and handling of the spent fuel and the possible weapon-making material is a concern, because you don't even need enough uranium or nuclear power, nuclear materials to make a full, nuclear bomb. Putting spent fuel rods into a regular bomb makes that a dirty bomb, which means even when it explodes, you're not going to have a giant, nuclear cloud like in Hiroshima or Nagasaki. You'd still have spent portions of nuclear material spread out over, the bombing area. When we talk about radioactive waste, we have low-level radioactive waste. That's radioactive solids, liquids, or gases that give off a small amount of ionizing radiation. These might be even things like the clothes, if you were, like the radioactive suit you were wearing, if you were taking care of radioactive material, old mining tool equipment that was used to mine uranium. High-level radioactive waste will be the solids, liquids, or gases that give off large amounts of ionizing radiation. So that's like the spent fuel from a nuclear power plant. How do we get to a long-term solution? Yucca Mountain is an area where we could bury it deep in the earth. It's tectonically inactive and is not near any sources of groundwater. As of 2004, the site must meet EPA million-year standard. So today, instead of planning for 10,000 years, we have to be able to predict that it'll be safe for a million years, which is really hard to do. The other possibilities for storing radioactive waste would be beneath the ocean floor, which I think is a terrible idea. On the Arctic ice sheets, which, because they're melting, I think is a terrible idea. And you'd have to have lots of security there, so we'd have to also pay for that. Above ground mausoleums, which isn't great. So I think Yucca Mountain or above ground mausoleums are probably the best. You want to be able to secure them. You want to be able to make sure you have security. And these two, I don't know how you would maintain security around them. We do have some temporary storage solutions, which you've already read about this year. So many store their spent fuel in the nuclear power plant. They have underwater storage and above ground concrete and steel casks. But we're really going to have to get a permanent solution, and we don't have one yet. So hopefully Yucca Mountain or an above ground mausoleum will be built and maintained. So right now they have a cover, they have the lid, they have a steel cannon, they have another storage cask around it, they have spent fuel rods. Here's the plan for Yucca Mountain. 70,000 tons of high-level waste will be put way down here in these tunnels. Each of these little network tunnels here would have the containers, the waste canisters, the spent nuclear fuel. And then you would just put it down through here. You'd have a ventilation shaft. You'd have a separate elevator essentially for people. And then it'd be pretty easy to maintain security. Although the area is tectonically inactive, there could still be some issues, particularly after Fukushima. We're more concerned about potential tectonic problems. Nuclear power plants, once built, are licensed to operate for 40 years. And recently, several received 20-year extensions. Once you shut down a nuclear power plant, you can't abandon it. So you have to either make sure you're storing everything in there, you're entombing the entire place, or you're decommissioning or dismantling it. So you can't just abandon a nuclear power plant once it's shut down. So they're expensive to decommission or shut down as well. How do we feel about nuclear power? Most people think it's a great idea, but they don't want a facility or a waste disposal site in their backyard. So we're back in that, not in my backyard. There's a lot of people who are going with the DAD acronym, Decide, Announce, and Defend. These are pro-nuclear advocates who base their opinion on science, or their statements on science and not fears. Fusion, fusion might be, fusion would be great. Nuclear fusion we can't do yet. If you could control the energy of nuclear fusion, we could produce lots of energy at very little risk, but we haven't been able to do it yet. But overall, nuclear power has great possibilities, but also great dangers. And so you have to make sure that you have a stable government in place, stable regulation, the willingness to continue to regulate it, and you have to be willing to invest money regularly to make sure that infrastructure is in place and it's properly maintained. I know someone who does who works at a nuclear power plant, and it's a lot of work, and it's just a lot of security and a lot of practice. Um, and so when the power plants are run well, they're safe.